is the Lamborghini V12, the pinnacle of automotive engineering. We're going to take you inside the factory for a full deep dive.
This badge represents the pinnacle of V12 heritage. At nearly $500,000, the carbon fiber monocoque construction is why this car is so special.
And this is where we verify the prepregs require storage at minus 18 degrees Celsius.
That's right, crucial for maintaining the material integrity of the monocoque. These aluminum extrusions are essential for the V12 subframe. And as you can see, every part carries a traceability tag and barcode.
We use the CMM arm to check the aluminum node's tolerance. Green lights confirm the specifications are met, and the data is uploaded to the MES screen. We've assigned the VIN and generated the build sheet. This confirms the Aventador specifications and the Giallo trim level for the carbon fiber monocoque. After badging in, we step into the cutting area. This automated system ensures every layer of the carbon fiber monocoque is cut with absolute precision. We use these desiccant pouches to control the humidity, ensuring the carbon fiber maintains its precise properties before layup.
This layup sequence is precise. Ply orientation is absolutely critical for the stiffness of this V12 supercar tub. The plies are laid into the mold and hand rolling removes trapped air. Careful draping at the corner radius prevents wrinkles.
Utilizing these aluminum hardpoint inserts allows us to co-cure bond critical load paths directly into the V12 monocoque structure. As the autoclave opens, we begin the critical cool down phase, carefully monitoring the gel time of the carbon fiber structure. Now that the curing process is complete, we can demold the carbon fiber tub. As you can see, these edges require careful CNC trimming. The CNC router maintains a mere 0.2 millimeter tolerance on the reference holes. This two-part structural epoxy is beaded onto the carbon fiber. We clamp the bulkhead securely, and now it enters the required clamp dwell period. The 80-degree, 45-minute cycle is critical. It activates the adhesive, guaranteeing the incredible bond strength required. At the NDT station, we use this probe to scan the monocoque. The C-scan image clearly shows green across the board, confirming zero voids or delamination. The laser tracker captures the reference frame, ensuring perfect datum alignment for the subframe mating points. With the jig secured, we drill these critical pilot holes. We must adhere strictly to the torque specifications shown here. This robotic MIG torch applies a precise bead. The precision of this weld is absolutely critical for the performance of the V12. We use advanced TIG welding on the Aventador class carbon fiber monocoque. Every weld, especially in these tight corners, is critical to the structure. Moving to heat treatment, we slide the subframes into the furnace, monitoring the T6 targets closely on this soak and cool curve to ensure structural integrity. The spindle spins up, machining this mounting boss to incredible precision. We're talking about a flatness tolerance of only 0.
The CMM probe verifies the hole positions, confirming the Lamborghini V12 supercar subframe is well within spec.
This powder coating process is vital. It provides the Lamborghini V12 supercar chassis with maximum corrosion resistance as it enters the cure oven.
Once the subframe arrives, we press the bushings into place. Then it's critical we check the part numbers and verify the torque specifications.
The bolts are first inserted hand snug into the alignment jig. It's critical we apply the structural adhesive precisely to these interface points before torquing.
The torque gun applies the precise spec in a cross pattern. You can see the readout confirming 150 millimeters. The rear subframe aligns as the locator pins engage. We secure it with temporary bolts, and here you can see the NVH isolators, which are key to the car's refinement. Applying the structural adhesive to the carbon inner frame is a critical step. These bond line thickness spacers guarantee the carbon fiber doors are clamped together. We monitor the adhesive squeeze out, and these vacuum cups maintain alignment during the critical cure dwell period. The key is the grip progression. We use a multi-stage sanding process, moving from 800 to 1,000. These belong to our Lamborghini V12 Supercar IN. As you can see, the Duracell robots are applying the primer. This specialized coating is essential for the carbon substrate. Here in the flash-off oven, we maintain a constant 60 degrees Celsius. This ensures the primer is perfectly uniform. The team is finishing the wet sanding now. Using the inspection light, we check for perfect flatness. Yes, this is ready for the base coat robots. Polishes. We use this viscosity cup to meticulously check the paint's consistency. This ensures every metallic flake. Now the robot applies the final wet coat. This specialized 2K clear chemistry instantly builds this incredible gloss you see forming on the carbon fiber. We monitor the cure chart closely as the clear coat hardens at 80 degrees Celsius.
The V12 supercars demand perfection. This mirror finish is exactly what we're looking for.
Approved for assembly. Portions. We scan the panels to the VN right here on the assembly line. As you can see, we use specialized anti-scratch glue. The torque wrench confirms the precise installation. And as you can see, the alignment on this carbon fiber monocoque is absolutely flawless. We secure the carbon fiber hood to these precise strut mounts. Once attached, we verify the smooth hydraulic motion. Now that the engine cover is secured, we move to the A-pillar. The pivot geometry here is essential for Having finished the body alignment, we transition to the powertrain hull. This graphic illustrates the...
Let's take a look at cylinder 4. The wash cycle seems to have done its job.
Image is clear, absolutely pristine surface tension.
Sequence complete on caps 1 through 7. Now apply final torque to yield, 60 foot-pounds plus 90 degrees. Torquing these rod bolts precisely is essential. This ensures the balanced reciprocating mass vital for the V12's performance. We align the chain precisely here on the timing marks.
Tensioners are set to spec.
Excellent. I'll rotate the crankshaft now to confirm.
Peichi. We use these multi-layer steel head gaskets for a perfect seal. Then we torque the head bolts in a precise spiral pattern.
With the cam covers off, we use these gauges to check the valve lash. Specifications demand absolute precision, ensuring the V12.
As the fuel rails lock in, note the spray pattern. These high-pressure injectors are critical to the Supercar V12's efficiency. We torque the manifolds down precisely, then fit these heat shields. This ensures proper heat management around the lambda sensor ports.
The dry sump system, featuring these scavenge lines and pump, guarantees oil flow to the V12 even under severe G load.
Please. The ISR gearbox utilizes these shift rods and actuators for instant shifts. The final step is...
Mating the V12 engine and gearbox requires absolute precision. Each bell housing bolt is torqued sequentially before final sign-off.
And there it is. Look at the torque curve spike. That is exactly the power output we designed for this engine.
As the bushings are greased and the aluminum arms assembled, we verify the geometry targets against the pushrod and rocker layout diagram. After greasing the bushings, the robot installs the control arms. We must hit these precise geometry targets for the pushrod and rocker layout shown here.
We mount the pushrod dampers, demonstrating the shaft resistance. Then, we torque the rocker pivots precisely. The 6-piston calipers are mounted to the uprights using a precise torque gun. This is followed by the essential bedding procedure for the carbon ceramic brakes.
With the corner module positioned by the hoist, we secure it to the monocoque. The torque pattern is initiated.
Once the main vehicle harness is installed, we ensure the ECU lines are correctly shielded and clipped securely to the carbon fiber monocoque bulkhead. With the harnesses in place, we connect the ECUs. We then scan the module ID, linking it to the VIN, and print the verification label.
The climate control unit passes inspection. We are clear for dashboard assembly to begin immediately.
We begin mounting the screen and cluster directly onto the monocoque. This specialized wiring loom connects the dash component.
With the dash now securely bolted and the HVAC lines connected, I'm checking the final fit of the Alcantara surface before we power up the system.
The column bolts are torqued by the system, and now I'm connecting the paddle shifter harness before testing the wheel travel.
Cheers. It's a critical balance. We use these NVH mats and carpeting to significantly reduce cabin noise, as shown here.
The seat rails are mounted directly to the carbon fiber monocoque. We meticulously check the torque on these belt anchors next to the Alcantara trim.
We guide the seats into the carbon fiber chassis. Once bolted, the adjustment range ensures a perfect fit for any driver, maximizing comfort and control.
Next, the center console array is installed. We test the start button beneath the red flip cover, bringing the cockpit electronics online.
The fluid capacities are precise. Oil, coolant, and refrigerant are pressurized. Now we monitor the brake bleed until those air bubbles clear.
After the fluids are filled, we mount and torque the Pirelli tires to the hub. We confirm the balance weights and mark the lug bolts for quality control. Next, we test the window regulators. Smooth travel is essential, and we listen closely for any anomalies or squeaks.
As you can see on the screen, the system is now making the final micro adjustments to the camber and toe settings, ensuring perfection. The system calibrates the V12's headlights to the exact cutoff point specified on the chart.
All right, the brake bedding cycle is complete. Deceleration profiles look strong, and the ABS modulation is confirmed nominal.
The shaker rig simulates years of abuse in just minutes. We're listening for any vibration or rattles from the chassis.
Now the key is to eliminate any trapped bubbles. Under this light tunnel, every imperfection is visible, ensuring the monocoque is perfectly protected.
Here in the light tunnel, we finalize the finish on the V12 carbon fiber monocoque. After the final polish and scan, I can sign off on the exterior quality. We ensure these protective transport covers are securely fitted over the seats and controls. They will remain in place until you take delivery. During this final startup phase, the ECU runs through its adaptation sequence. Watching the RPM stabilize confirms the build is complete and optimized. Having finalized the build process here in the factory, we're ready to guide this V12 supercar out into the daylight for the first time. This V12 supercar represents the pinnacle of automotive design. Just look at that carbon fiber monocoque shine in the golden hour light.
This is what sets Lamborghini apart. The consistency of these panel gaps and the solid feel demonstrates world-class manufacturing precision.
This belongs to our Lamborghini V12 Supercar VN.
The V12 Aventador rolling out now. What a machine.